Hi, good morning, everyone. Welcome back to the session on Python for data science. We're so pleased to have you here again on a Saturday morning, and we're super excited to resume our sessions on Python. Good morning. Good to see all of you here. We've had a lovely week before us. We've had a lot of submissions for the 7 Days to Data Science challenge. And it's like over 200 plus submissions right now. Our trainers have been really having a tough time, evaluating all of the submissions. And there's some awesome ideas that have really come out of it. And we can actually see, that there's a lot of innovation happening in the space with very interesting concepts and concepts.
Hello everyone, good morning. This is Suvir Bhatia, the instructor for this class. I hope you're able to hear me. So I can see Ananya Sharma out here in the lecture. Hi Ananya, good morning. Okay, so okay, sure, thank you. Ananya, can you not hear me? Hello, can you hear me? Okay, great. So Ananya, good morning and welcome to the class. Welcome everyone into the class session. We are going to study about Python in continuation. So anything that we have studied the last weekend, is there a thing that you can tell me? Ashish, welcome. So can you hear me, Ashish? Okay, so in the last session, we worked a bit on the Python core, correct? And then we had couple of topics which we had to conduct. Okay, so I can see, yes, Priyanka is there, Ashish is there. So welcome back, guys. Smita, so I hope you're able to hear me. Rushali, Shubhendra. So we have all the people coming onto the session. So welcome, guys, back. Okay, sure, thanks. Good morning, Sharad. Sure, thanks, Ashish. Sure, thanks, Tejas. Okay, So let me go ahead and share my screen and we'll continue with where we had left off. I have also shared my screen, so please let me know if you can see the screen as well. So anything, guys, that we can discuss what happened in the last session? Anything, any revisions that you have on your mind? Did you get a chance to have a look at the notes? Did you get a chance to have a look at what we studied in the last session in regards to Python core, which we have been doing? So we've studied about lists, about tuples, about conditional control structures, about the functions, about the user-defined functions, isn't it? Exactly. So we have we learned about the dictionary. We learned about the function, about the sets. Yes, Yogita, we learned about all these things. Sets, functions. That is correct. That is correct. Absolutely. Thank you. So so yes, so we learned about functions and we learned about dictionaries, right? So dictionary has a key value pair and functions is like a UDF or maybe a custom function we can create. Just give me a second, guys, here.
Okay, we're sorry about that interruption in between. Sorry about my session got logged off in between while we were just starting. So while we give Suvir a few minutes, let me just conclude on the introduction bit that we were on. And we've got some exceptionally good ideas, right? That we got from the submissions for the 7 days to data science, course that we were doing. So 7 days of data science. Now, what we've seen is interesting concepts that came up were really in the sense of we've had people who've actually come and made submissions, such as there are caddies, which you have in golf tournaments, who actually help you choose which is the proper golf stick to actually use to, put the ball into the, put the ball into the goal, right? Sorry about that. So there are experts that actually advise you on how to hit it, etc. How about you could use AI to tell you? AI could be your new caddy when you go to the next golfing tournament, right? That's the expert. Your cell phone is going to be the expert, which is going to tell you how to actually, do something. So it's very interesting, from that standpoint of what all various different ideas and concepts have actually basically come up from the 7 days of data science challenge. Now, for all of those of you who have actually not yet made a submission on 7 days to data science challenge, you still have the opportunity to submit. So don't forget that. So the submissions are open till 11:59 p.m. Today evening. So you have like more than 12 hours at the moment to complete all of your submissions. And once you're through, we will, in tomorrow's session, we will actually announce the winners. So we'll announce the top 3 winners. Now, keep in mind that we take the best 7 submissions. We don't take the first 7 submissions. So if you're lower ranked on the leaderboard, right, you want to increase your rank, nothing to worry. Just keep submitting as many as you want, right? Just submit as many entries as you want. And you could submit 15 entries, 20 entries, 25 entries. There's no stopping you, right? The exercise is actually more of a data science mind, it's basically a thought building experiment, wherein the exercise really allows you to start looking at everyday problems that you encounter. And it starts to allow you to think on how we can use AI and ML to maybe address those problems or better those problems or increase optimization, right? It allows for all of that to kind of happen. And that's a really essential part, because when you go on to becoming a data scientist, data science it's not about really writing programs. It's not, the programs in data science are hardly 20 lines long. So this Python notebooks that you're currently using actually have more lines of code than most data science programs. And it's just about taking a few libraries, using them, in specific use cases, and you will have your data science program. So if programming in data science is that easy, why do we say data science is difficult, right? And data science is difficult not because of the programming bit. Data science is difficult because most people who do data science actually do not have domain understanding of the subject that they're doing data science for. So they really do not understand they do not understand the data of a particular domain. They do not understand how do you use that information in an analytical problem. And they do not understand what models to use to address the problem or how to address the problem, right? Sometimes data is insufficient. Data is actually not structured. Data is missing. And most data scientists are not able to figure out what do you do in such situations. They're not even able to take the right decision on what data is really important to get a particular outcome. So what you see in the contest, right, we have basically asked you to also tell where the data will come from, how will you use this data, how will you solve this problem, right? So that data is also one of the most important things. So I can see some of you are saying you've not actually, made any submissions. So that it's not late. So you have time till 11:59 p.m. today. You must make minimum of 7 submissions by then. You can make more than 7 submissions. And if you make more than 7 submissions, you stand a better chance of winning. So you can go look at the leaderboard. So congratulations, first of all, to all the people who are leading at the moment. It doesn't mean that you will continue leading, right? Because keep in mind, others can submit more. If anybody has got a full score, then you can't get better than a full score, then you're done, right? Then there's nothing more to do. If you don't have a full score, you can go and make submissions. But the exercise is mainly from a thought building perspective, which is really designed to allow you to see where all data science is covered. And in the session today afternoon, we will walk through some actual submissions that have come through. And we will also see the leaderboard ranked up to 11:59 p.m. Yesterday night. So the current leaderboard that you see is Thursday night, 11:59 p.m. We will show you the leaderboard for Friday night, 11:59 p.m. by today evening. Thank you so much, Mohit, for the T-shirt. Yes, we got these printed while we were at a conference, and I like it too. It basically says, I don't know if you can read it. It says, "Data science revolution is coming. The data revolution is coming." I don't know if you can see it, so I hope you can. Yeah. Thank you so much, Mohit, for that. And yes, so let's wait for Suvi to set up. I think he's still setting up his Cloudbooks, so Suvi can resume once he's ready. Until then, let's give him a few minutes to get the Cloudbook up. And by the afternoon session around 4 p.m. before we close, we will walk through some actual examples of submissions that some of you have made, and they've been really, really phenomenal submissions. And I think that's really good value addition to everyone to start, opening up your minds to think about, various ways in which AI and data science can be used. So over to you, Suvir. As soon as you're ready, maybe you can resume. So, yeah.
Sure. Thank you, Sanket, for that. All right, guys. So let me share the screen here. I have shared the screen. I hope you all are able to see the screen. So this is what we're going to look at today from the technical standpoint of view, guys. So functions in Python. Prior to this, we have studied different lessons like this. You can see I have also zoomed in my browser. So I hope you're able to see the text. So we learned about the set, about dictionaries, about sequence functions, correct? So we learned about lists, we learned about tuples, the grammar of the language, and the basics of like hello world. So I hope all the other topics you have gone through, you have made a good revision, and we are in process to understand what are functions. That's correct, absolutely. So we'll go with the functions part. We have covered to some extent, we have covered how to define my function. We have also covered how do you define my functions with other conditional and control structures we have written. We understood that function is defined using a def keyword, which we have been using, the name of the function which you want to provide, and the arguments for that, correct? So if you want to add two numbers, we will specify two arguments which will be passed. So let's directly jump to where we were. So we started with returning multiple values, and before this we saw how do we get the returning values. All right, so there was a case where we had to write the return keyword, and there was a case where we didn't. So we can use both ways, but I always encourage to use the return keyword because that's what we saw in this function, that we have a return and without return, but that's fine. So let's go with returning multiple values. So when we are saying that when you define a function with some name and the argument, so in this function, line number 14, we can see that there's only a single argument. But when you see the return value for that, is you give me a square of that function, or you give me a cube of that function. So how do you get these values as in? So the moment you say that you give me these two returns, so you have to also unpack. You know, we had learned about unpacking the tuple. So you have to unpack the tuple in order to store the result. So the 3 square is x2, which is actually a variable name for the tuple. And another 3 cube is actually x3, which is the cube of the number. This is what we had done last time. So the above function returns both the square and cubes of a number. It returns both values in a single return statement. Let's see, it is important to spend some time how this actually worked. Is the function really returning two independent objects or a single one? And then we are unpacking it. How does it go? So the function is returning a tuple, and within the tuple we have two items, and these items are getting unpacked as we've seen before. So however, what we have done is we have created a tuple inside a function and then unpacked that into two variables. Okay, so let's test this hypothesis. I hope you all are clear. So we are saying whether we define the tuple inside the function or we made the tuple while unpacking it. So we can unpack a tuple, as we know. So inside the function, we created a tuple. So instead of you simply saying return x square comma x cube, you could have said return open bracket x square minus comma x cube and then close the bracket. So let's see this one. So square and cube, you give me a my value. You load the values of square and cube into a variable called as my value, and you will see that the type of this my value variable is actually a tuple. So when we assign the returned value to a single variable called as my value, so we get two values added into that as a tuple, which is nothing but the 4 comma 8, because the 2 square is actually 4 and the 2 cube is 8. Very straightforward and very simple. So we can have control. So similarly, we have an underscore here. So underscore itself is also an object. So we can have control over the unpacking. So this allows us to custom unpack and cherry pick the value. So if you have around 10 vectors created, 10 elements of tuples created, and you would like to pick only a couple of them, then we can use this. So print of x2 comma underscore and square and the cube, again the function, and we're simply saying you print x2, so it's just going to give 9. So we can see that we are able to ignore the second value of the tuple and picked only x2. It worked perfectly as desired. Even if you would have kept another variable name, still it would have worked perfectly fine. And same goes with the other way also. Underscore comma x cube, print x cube is going to give you the same result. So we skipped x2 and created a variable for x3. So this is a good point, that it is needless to mention that you can return anything from a function that we have been saying. And just to be in the best practices, always ensure that you use a return keyword inside the defined function which you're writing. So the return could be a list, it could be a dictionary, it could be a set, or any other object for that matter. So you can also return dictionaries and sets. So how do you return that? You simply specify return around curly braces if specifying returning dictionaries, or using a standing bracket if you want the values to be returned into a list. So let's see, can we return the value into a list? You can see that this is the function, and we are saying that you return x square and x cube, and the only difference is that we did not specify the default round brackets, or we did not specify nothing at all, in fact. So but here we have specified a standing bracket, which means that you give me the return data in the form of an array, or more or less give me the data in the form of a list. So let's see, can we return a dictionary? So let's see, this is the dictionary. So you return x2 x square in the x2, and you return x cube in the x3. So I hope this is very straightforward, and we are just saying that you give me the return. Okay, RET is actually a function. So you give me this particular function for x2, and you give me for x3. So returning the tuple is the most recommended and the most practiced approach in Python. So it's saying that if you're creating a function, that most of the time it should be returning tuples. And generally tuples are lighter and faster than arrays and dictionaries. So there is a point that generally they are faster and lighter. That is because of many reasons, because tuples generally they are immutables. So if they are immutable, they don't have to literally traverse the indices, and indexing in tuples are quite seldom compared to lists and other objects. So that's the reason they are lighter and faster. Functions are objects. So let's see this. So a very important concept is that all functions are objects. In fact, not just functions, but any object in Python, they are all objects. This is not just some theoretical concept, but they are objects like behave any other object. So let's see. This means that functions in Python can be passed as arguments to other functions. Really, let's see this. And they can also be returned from other functions. We can add functions into an array or store them into a dictionary. Let's see this, how we do it. So this is straightforward. Define square and cube and return me two values in a tuple. I'm saying you load, you say my func is equal to square and cube. Okay, x2 comma x3 is equal to my func of 3, and then you can see that my func which we have returned is literally behaving just like square and cube function. So what we have done is that Python has actually allowed us to do an equation to equate this function into another variable called as myfunc, and then myfunc started to literally behave like our previous function, which was square and cube. Okay, so how did this? So interestingly, Python has allowed us to set the variable to myfunc to be equal to that function. Now this has now resulted in both myfunc and square and cube to be the same function. Okay, it is now the same function with two independent names. It's pretty clear, right? So let's say when you import the data in any of the from any of the repositories in Python also, and when you load the data into another variable, the data is replicated twice, correct? It's not like, so it's straightforward here. So when you have created a function, and if you wish to change the name of the function later on, the simplistic idea would be to load the function into a new variable, or basically into a new object with a new name. So let's say, is it a duplicate of function? It is not true that we have created a duplicate of the function. We did not. Square and cube in itself is an independent object. This can be passed around other functions as parameters. We simply assigned object another variable name. Okay, so let's try our function, which is an object to another function. So let's say we create 3 different functions here, and the name is the square function, the cube, and process 3 is nothing but func3, and we'll see what happens in the func3 part. Okay, so we'll go and we'll say, so the square and cube we know, so the moment we say the square and the number is going to give us the cube and the square. Let's see what happens here in the process 3. Now, process 3 square and then process 3 cube, it gives us the result back. Now, what has happened? Initially, what we did, we renamed the function by loading that into another variable. This time we are using the function as an argument. All right, so these are the two different things. So please not to get confused. See, I'll tell you, there are a lot of questions which are coming as like, what are the real use? See, it's right now for functions, relating it to a real use may be a little difficult for me, because these things comes as you move on in programming. These things comes automatically when you encounter a particular problem statement. Data science is actually being reasonable to data, so you have to think rationally. So if you are using functions to solve a particular problem statement, it's not necessary that any other developer would do the same. He might use any other logic. So So what I'm trying to say that technical writing codes is really immaterial to your problem statements. I can give you practical examples on like how what kind of functions we can write in order to enhance the functionality of a particular model. Okay, but when it comes to kind of explaining about where are the examples of putting this one, we can work on any example for that matter, but it's purely based on what is the requirement. So let's say if you're working on computer vision or image classification problems, then there could be a need for you to write a nested function. Or when you're working on text mining applications, or when you're working on simply general purpose programming, maybe for your scraping of your data, that time you're using functions, nested functions. So I'm not sure if people have heard about Scrapy. Scrapy is actually an input output library to harvest the web channel data. So you can actually scrape any data from any web page, but in an ethical way. So that's why the Scrapy is used. So in Scrapy, you write thousands of different functions, which helps you to pull data from various different channels very conveniently. That is correct. So yes. So I'll try to get the examples wherever it is relevant. And I can get you examples where we can bundle this together, So this is a good example of replacing your function argument with another function. Okay, another Python function. So replacing your function arguments with another function is primarily this line of code is into. So we are defining a new function called as process3, and the arguments to that is func, which is nothing but just an argument over there. And right now, if you see, we are saying process3, and just func, you can take this as an x as an argument, and we're replacing that with our actual function that is square and the cube. The above example can be a bit hard to comprehend, but we have defined three functions. The primary invocation is process3. This performs the processor number 3, and this number 3 is hard-coded with identified as this one. So print of func3, you can see over here, is actually, you can see this is actually the main. So the line number 3 is above is the hard-coded 3. So this process invokes, so you can see that, there's been a func of the 3. So this is where we are passing number 3 as an argument or as an argument value over there where you would need to calculate. So you can calculate for number 3 for function square and cube. So however, process 3 is accepting func as a parameter. This means funcs can map to any function that takes a single parameter as an input. And similarly, if you have functions which more than one parameter, you can pass func comma another func over there. It is also important to note that func must also return a value, else there is a chance that print statement will fail. So that's what we have done. In two independent invocations, we pass the functions square and cube as parameters. That's what we have done. Both square and cube are an object, and both objects are a function that accepts a single argument. Now, this needs to be taken care of. So it shouldn't be this way that there is another function which is taking two arguments, and you're trying to fit that function as an argument to another function which has got only one argument. So that time you may run out of and come out with an error saying that second, you need to pass the argument you need to pass the value for the second argument. You get some error, something like that from Python. So when we make the invocation, depending on what's a func3, when we actually did this, Depending on what func is assigned to, it is equivalent to either of the following. So print square of 3, which is actually print func of 3 is nothing but print square of 3, or print cube of 3. That's what we had seen in the function. If any issues, I can explain it. I can also write another function for you to explain this part, but I hope this part is clear. It's very straightforward. Let's look at another example with the same thing. So define number, return the number, define square, you define the square of that, and return the cube. And you can see that the process 3 is a new function. And I'm saying the function is equal to num. So more or less, if you kind of, you're saying that my argument to this process 3 function is nothing, but it's actually a function. So what happens is when I say process 3, it is simply returning the number 3 to me. Or if I say process 3 num, it's still going to return 3 to me. And if you change this func is equal to square or func is equal to cube, and then you say print func of 3, it's going to give you 9, both sides. And same goes with 27 if you are trying to use a cube. Straightforward things, and getting examples for this one is a little difficult. So what happens, I'll tell you guys, when you write program, you don't actually do it blockwise the way we are doing it right now. When you start writing a full-fledged program, you actually get a mix of all variants which we've been studying, right? So sometimes you may start your program with defining variables first, and then the second part is you might get directly pandas, or you start directly with numpy, wherein let's say you want to fetch some sample numbers, you want to fetch some random numbers, or you would want to define not a number values to your data for any scenario for that matter. So you're going to use np.nan and all those kind of stuff which we'll be doing. I'm not sure if numpy is there with you. I think it's planned for today. So can we consider func process 3 as a wrapper function for both square and cube? See, actually, yes, what you have defined is in a form of a wrapper function, but typically they are still independent to perform their own functions. Okay, so it's unlike any programming language that you have defined the wrapper function and it's going to behave only as a wrapper function until the life cycle of the function is. But in this case, you can see the square function has its own life cycle, cube has its own, and process 3, as you've been saying, that wrapper function, you can say that, but still I would say square, cube, or any other function is still independent to perform. So in the above example, we have created an additional function called num, and in the function, we have not just given different name, or we have equated that function to another function argument. And then directly we have used, so num being the default value for that. So when we simply left the process to blank, it gave us the values. Okay, guys, so I hope the custom defined functions is becoming clearer and clearer to us. I'm sure that you have to practice this part, and I'm sure we should also be looking at some examples which we have planned. But first we'll finish these topics and we'll then go on to that part. So Lambda functions is another type of functions in a user-defined functions. Okay, so guys, this is all straightforward. Let me be very honest, and for people those who are quite new to this should not worry about this because it's very straightforward, as we are saying. I think when you look at this for the first time, it might create a worry, but when you look at this for the second and the third time, I'm sure that you'd find it really, really simple. So what is Lambda function, which is a part of UDF, which is a part of user-defined functions? That's correct. So solution team has a question. Process 3 cube should also return output from cube function since default was absolutely, as I said that before. If you even put a square over there and you put a cube, it's going to return all kind of outputs to you till the time it has got the argument number like a 3 or 2 or 4. You need to provide the value over there, yes. So what are Lambda functions? So these are also called as anonymous functions. What are anonymous functions? Anonymous functions means which has no name, correct? It has no name. So this is a way of writing functions in a single statement. So see, let's say, why do you create functions firstly? Okay, now there has to be a reason for you to create functions. We create functions typically to save time, and we also create functions to kind of repeat for the repeated task which we may have, uh, or for the mundane tasks which you may have. You may also call those things as a utility functions, or sometimes also known as helper functions. So what does a helper function do? I'm sure programmers out here must understand that part. Helper functions kind of does your repeated task like connecting to a data source, connecting to some tables, getting, collecting some files which were there on your on the server, comparing it with some other files, and then returning the output to you. So let's say, just to give an example quickly, every day there's a developer who and the team has a mundane task to pick up the list of files from 2 different folders and compare it with each other and give the result. Okay. So every time all the developers used to maybe write the code, change the parameters, etc. So the manager actually created a code or a function which can be used by the entire team to do the same kind of job every morning. So simply create a function and all the team, every other member in the team is likely to use that function. And that function can have maybe thousands or 2,000 lines of codes, okay? So now you can see that even if a new entry is coming into the team, like a new developer, he simply needs to be educated that in case if you're looking for such functionalities from your system, then you are supposed to use this particular function. Okay, and that is what the usually happens in the team. Okay, so developer starts to follow whatever is present in the repository, which is given to them by the team, and they're going to use it accordingly. But what if there is a need for you to map an existing function? There is a need to filter specific values using a function, or there's a need to create an anonymous function. What is an anonymous function? They're a function which has no name. So this is a way of writing functions in a single statement, and the result of the function can be a non-return value. We use the keyword lambda to define a lambda function. So in the previous section, we studied how do you write a custom function, and the way for that is def square of x, and you return me the x square, okay? So by using a lambda function, we can define this function in a single line as shown below. Let's see this one. So let's say if you want to define your lambda function, you can very well use a keyword called as lambda and just specify the arguments which you have and keep moving forward the way you've been doing in your regular function. So lambda of x colon x multiplied x is going to give you the square for that. So the square for number 3 is actually 9. So you could see the difference in both the lines and how you actually create a lambda function in contrast to your regular user-defined function. A couple of things to note in this. Can we use exceptionally different kinds of code in lambda functions like a for loop, because the for loops can be written very well in this user-defined functions, the regular functions. In this, do we have any flexibility to write conditional statements, for loops, any other thing for that matter, what we get in this one? So the answer is yes, we can do all those kind of things, but we still need the answer. What is the significance of writing lambda function? I'm going to come to that after we finish this one. So whether we define the square or lambda keyword, they both produce exactly the same output. So why have we using lambda function? So the answer is, In simplest forms, they make programs more elegant. Now, firstly, Lambda functions are not hidden from the actual source code. The advantage of user-defined functions, which we studied before this, the advantage for that is they can be actually hidden from the main source code. And if you create your entire front-end code using your user-defined functions and you have wrapped that access to those functions, then no one can actually decode your code, because they don't have access to the actual functions which they have. But in Lambda functions, they are very well visible in the source code. So it involves lesser typing for coders if you go for Lambda functions, but in some scenarios where you want to pass complex things, it is much more convenient to make an inline definition. What is an inline definition of a Lambda function? Means inline is like writing in place or writing explicitly over there that have a full-blown functional. So let's take a look at our process3 function and how we can create process3 using the Lambda functionality. So define process3 func, and then we have instead of you specifying arguments, you've actually specified the entire function. Okay, and you can see, so we are saying process3 lambda, your argument is x, and then the square of that. That's a good question. I'll come to that, Aparna, in just a moment. Okay, so there's a question by Aparna. She says that we have defined the name of the function as a square function. So why it is still known as a lambda function? That's a good observation. So this is just to test that hypothesis of what we are saying. This is just a demonstration of when we load the lambda capability into an object variable, does it really perform the same? And it does. Okay, that's what we are seeing. So square of 3 is actually returning as 9. But where are we using the lambda function? Either we are using this way or we are using it another way. That is correct. But just coming back to answer that question, now you saw that we created my func, or a function name, I think func, right? So we assigned a variable to that, which was nothing but eventually a copy of the original function. So you can more or less take this the same way, correct? So we saw an example that I am loading, this is my function 2 is equal to function 1. You saw this, right? So when we actually copy function 1 into function 2 also starts behaving the same way. So this is also, you can take it that way, that this one, the entire line here, it behaves like a function 1. Whether it has a name or not, it will still be copied into square. I hope that clears the confusion. And this is how we pass the lambda functions to process3 lambda of x, and we define the complete method. In this, you will see that we don't require to use return keywords. So the return is kind of, it's by default, which is expected from Python. Correct. So it is much shorter code. So over here, we did not define the function called square and a function called cube. We simply, so yes, again, just to answer to your question, we did not define anything that is called as a square and a cube. And still, we can still use process3 as different ways of output. We can get it in a square way, we can get it in a cube way. Exactly, Aparna, I hope that was clear. Yes, exactly, it's inline. All right, so pretty straightforward in the Lambda function. There are a couple of more things here. We'll look at that quickly. So let's say now we could write the function in a more elegant way. So let's see this one. Now this is actually the main part, and I will also show you the Lambda function other usages. So process3 is equal to whatever we write here will become the function here. Okay. So lambda of the func, which is nothing but just an argument, and print the func of 3. Okay, so it's just an argument that is 3. I'm going to say process 3 lambda. This is going to give square, and this is also going to give cube. Okay, and this is going to return cube. So in real scenarios, we're going to write functions this way: lambda of function, print of function 3, and then you have the process 3 wherein you're actually passing the values. Let me run this one. 9 and 27 is actually the return values. You can call that as an inline function, Abhishek. Yes, lambda functions are like inline functions where you define them explicitly. Okay, I hope this is very clear. So the second one is giving us the 9, and the third one is giving us. So what we did was simply loaded process 3 with the methods available into that. So the method was to, get the cube and the square for number 3. And when we actually passed the function, it started to give us the results. Little confusing for new people, but yes, the what thing we can gauge from is that there's not a single way to write specific logic in Python. So if you want to achieve a specific logic, that can be written in many different ways. That purely depends on which way is more comfortable to your understanding and which way you can use to make the codes more optimized. Some people use for loops, some people use apply functions. So it depends. Let's go with currying functions. So what are currying functions? It is a concept that allows us to create additional functions from existing functions. It involves partially applying arguments to the function to create a new function. Okay, let's look at this. So define sum of a comma b, and when you say return a plus b, it's going to give you the relevant output. And this code is very well understood. There is no explanation required for this one. It is straightforward. So the above function is very simple and simply does the summation of numbers. But what if you want to create a function that adds 10 to any number that is passed as a parameter to it? So what is the problem statement here? That we want to create a function that adds 10 to any number that is passed as a parameter. So if you're passing a and b as a parameter, it should add 10 to that. Let's see that. So we can create a new function that looks like this. So define sum of a, you return a plus 10. Okay, so it's going to give the job, going to do the job. Or we can simply use a previously defined sum function by creating a curried function. Okay, so let's see this. So this is the curried function. So we have already created a sum function. You can see here, this is the one. So define sum of a comma b, and you return a plus b. Okay, so let's see this one. So add 10, lambda of a, sum of a and the comma 10. And then we are simply saying print add 10. You pass 5 as an argument to add 10 in place of a. And the moment you add 5, then there is a 10, and it's going to add up those numbers. And why do you think it's going to add up those numbers? Because in the previously defined sum function, there is a plus sign here. So the sum function is ideally taking 2 arguments, correct? So when we pass this into a lambda function, we have to specify 2 arguments to this, correct? And the 10th one is the argument b, and argument a is just the a. So when we're using the lambda for the sum, we're saying add 10, which is 5 plus 10, the answer is 15. Yes, exactly, Santosh. It is calling twice. So sum we have already created, and we want to curry that function, right? So currying function is like you want to scoop it out. So we are simply saying that we understand that you have um, some as already defined already created function, and we would like to pass second argument into a lambda function. So we can previously use define some function by creating a curried function. This is actually a curried function. Sorry. So in a single line, we defined a new function called add 10 that partially applies an argument to an already existing function. We have fixed the value of b is equal to 10 when creating the curried function add 10. So in this case, the first argument a function sum is said to be the currier, and the resulting function add 10 is said to be the curried. I hope this is clear and straightforward too. Now, not just this, but this you can take this as a jump start, guys, because in the original practical codes, we actually combine a lot of things together to get one output of that. We use pandas in the data frames. We use user-defined functions. We use map functions. We use filter functions along with lambda functions. So there are two more different functions, which are map and the filter function. And I'll just give a very short brief of that over here. So map, you can see, is a function, and there's another function which is filter function. Okay, so let me just go with the map. I'll come to the filter once you finish this. So you can see when you go to the map function, what exactly a map function is doing. You can see there are two arguments to map function. Okay, and the first argument is saying that it should be a function, and the second one is saying it should be an iterable. Now you can actually use where we use in the codes practically is, let's say you have created a function to add the numbers or anything for that matter. That function has got some function. Okay, you want to map that function whichever you have created with the iterables which you have. Okay, iterables could be, we saw there what are iterables, right? Lists is an iterable, tuples are iterables, all these things. So when you map a function with the iterables, so whatever the method of this function is going to do, that is going to be applied to these iterables. So that is one function which is used along with the lambda function. What I meant is, in most common, along with lambda function we're using, you can see again there is a filter function. The two arguments are there. One is a function, and the second one is an iterable. Okay, again, the second one could be a list or anything for that matter. But here, this function, you can either use a regular user-defined function, or you can use a lambda function out here. In practical scenarios, which people are asking, in practical scenarios, we usually use lambda functions either with filter, because in filter function, you don't generally have, when you move forward in the code, as you move forward in the code, you realize what changes you need to make in order to get to the output, right? So let's say you want to filter some data, and you have already written a function previously to this. You want to filter some data, and you have no available function to give you the output. You write a quick lambda function over here on a list of object which you have. So that is the one of the uses. Yes, you can do that. So Aditya, you can so add 10 function further can have two arguments. Yes. And Mayank, can we change value and add 10 to other value? Yes, you can do that. Add 10 is just a name. So you can very well change the values in that line. So any questions, guys, in this part? Actually, I'm not very familiar with Scala, but if your question is that are Lambda functions in Python very similar to those in Scala, then I believe so, but I'm not very sure on this part. I encourage you to do a double check on this. But yes, as far as the logics goes, if there are any Lambda functions in Scala available, then they should typically more or less do the same job. So guys, this way we conclude functions, and I hope it was an interesting part. There are other aspects to functions also, but these information which we are getting in the training is a good jumpstart. Very well, we can pick these items, practice them, and can extend our skills and knowledge from these notebooks onwards. So I'm going to go on my second lesson, which is files. So in Python core, this is in this context, in this syllabus, lesson 9 files is going to be the final lesson for us, guys. And in this lesson, we're going to look at how do we handle files in Python. My request to people is not to think this as from the data perspective, because we're going to cover the data part moving forward. But in the files, we are actually talking about the CSV files and any other files which we may use as objects in Python. So these are typically the system files like log files or text files or CSV files or any other files for that matter. So, and we're going to see how we handle these files. Aparna, I've come on to the files topic. So if you don't mind, can I answer that once we reach at the end of today's session? There's a question by Aparna saying, can you tell more about the map function? Yes, I can, and I will. So maybe we once we finish the files, I can take you there. I can just show you some documentation, Aparna and Pooja, for the map and filter, but let's see if the time permits, I'll definitely get you an example on that. And that is also an interesting part, because that is what we use that quite frequently, quite often that is used. So Python is very popular when it comes to working on text files. Yes, Akshay, you're right. So no problem. I'll try my best to give you a simplistic approach to map and filter functions. But we will first come on to these files, and then we will go on with this topic. Okay. Coming to the Python core. Now, guys, Python was released way back in 1993, correct? 1993, 94. And since then, Python has been quite famous into doing the general purpose programming codes. Okay, so by 98 and 99, Python was widely used in the server rooms to manage their log files. Whatever server log files are coming, the primarily job for Python was to pick those files, read the data on those files, create new files, dump them in somewhere, and also it was used in systems programming. Then later on, Python started to become famous for its data science and for analytical libraries, which came up in Python regarding which was pandas and numerical Python. And then later on, that was extended to SkyPy, and later on to skitlearn, and all those kind of packages started to add value in a language called as Python. There are still questions from people how Python is different from R programming. They both are literally different. R has its own significance, wherein Python has its own significance. Python is more popular because it is widely adopted by the community, and it has got many libraries on top of it for supporting many various analytical needs. Okay, so we are going to work on text files in Python, which is again a general purpose usage. So many developers prefer to use Python when it comes to working on with text files. And Python offers several ways of handling libraries, and in scenarios like pandas, which are typically used to handle files, file-based operations. But pandas is used for file-based operations to read the data and manipulate the data. It's not to actually transfer files from one location to another, or kind of an activity wherein you want to open the file and write some content and then save the file back, something like that. Okay. So from the general purpose usage, let's say where Python was being used. So from the log files, as I said, so let's say the purpose for Python was to open a particular log file, print the timestamp in that, close the file, and transfer the file to some other server. Okay, let's say this is the task for the Python. So this particular session or the notebook is relevant to those kind of scenarios wherein you would like to locate a file, read the contents of the file, write some contents of the file, save it, and transfer it to some other location. This lesson is not about analysis of data. So let's get started with reading an already existing file. So we're going to read a file, whatever location we have it. And we'll simply read the file and simply print the contents of the file. We will read the file and we will print the contents of that file. Okay. Now, one important thing is there is a option to get the current working directory in Python. So you can see that you can say get cwd in Python if I'm not wrong. I generally stopped using that command, so maybe I can try it here. If it doesn't work, then you can help me in giving the syntax. I think it works with OS. So we have an OS, so OS dot, you can see that we have an, okay, it is here. So you can see that we got a method in OS library called as get cwd. Okay, so what I'm going to do is that you give me a print of cwd. Okay, you can see that this is, I'm opening from my local machine. That's why we have the path over here like this. If you are on the BlobCity Cloud, then you're going to get another path of a username / your file. But always ensure that when you're working with file-based operations, those files are already present in your working directory, or you provide an explicit path to that file. Okay. So let's look at this one. How to read a file in Python. So is this location there in my working directory? I'm not sure. Let's see. So, and these are these commands which you see in this particular lesson. Yes, these commands which you see in this particular lesson are actually coming directly from Python core. We are not using any libraries. And just one more thing, guys, so far you must have seen from our last weekend sessions up till today is that we have not imported a single library. Okay, I just use this here for the get cwd, that is import OS. I just did it right now. But in on our context of creating vectors or tuples, or maybe list or any other dictionaries and functions, we never imported any library because we are purely dealing with Python core, which is just the base language, or you can say out of the box. So we've been using this out of the box, and we have not top it up with any library package, which we're going to do once we move forward to more data-centric writing codes in Python. So let's say this one. So I've created a variable called as file, and I'm using an open keyword. open keyword in Python, and that's saying that open some file which is present. I'm not sure if this file is available with me. Okay, it seems that it is working, so that's great. So do I have anything called as data? Yes, I have it. I just checked it on my screen. So I have the data kind of a folder located in my working directory. I assumed that this data folder might be missing, but it's not. It's there, and I can see that there is a lorem.txt file which is present inside that folder. And very well, what I can do is I can say for line in the file, you print the line. So what it did, it actually opened the file. So this actually got opened in memory. Okay, so this got open in memory, and then I'm saying for line in the file, you print the file. It got open in memory and then got loaded into this particular variable. Okay, and this you can see that the file, these are the contents of the file, which I have read it from that variable. Okay, it's a pretty comprehensive file, it looks like. So we used, I will not go very far from my code. So what I can do is I can go to the cell current output, you clear the output. So we use a built-in function called open, which is out of the box. And the file to open is specified by the parameter which is passed. So the parameter passed must map to a file that is actually present, as I said. So the above output looks like a one big block of text, but we read this output line by line. So if we wanted to find out where the line breaks, so that is a little difficult. Okay, so we'll come to that in just a second. So we saw that when we print the line, it started to read the line by line data for us. Correct. So I hope this is clear. Guys, not to get confused between this line, it's more or less writing the same things what we learned before. Let's say for I in the file, which is we have, I'm going to say you print my I. If I run this code, it's going to return the same results than what this code is going to return. So don't get confused in what we learned before. If you have any questions in this line part, so it's just it's just a fictitious variable which you're writing over there. Okay, so but there's a problem in this output is that if you want to find where the line breaks in the file, Abhijit, import OS print. Okay, I'll just go and no, this one should be the one. Import OS. Are you working on the Cloud AI on BlobCity? What is your platform for Abhijit and Swapna? So even if you're working on the BlobCity, then you should simply get Jovian/data, or you should simply get Jovian related to that. Don't relate your path with my path. My path is from my local machine. So wherein the sun is the username which I use. And this is the other path for that. So downloads is where I have this file located. So in your case, you should simply get the Jovian and the folder. Okay, so we're going to say that we don't really understand if you give the output here, we don't understand the starting line out on this part. So we wanted to find where the line actually breaks. So what we can do is we can add kind of a prefix arrows just before the output. So you can see we can say the file is, of course, it's an open data lorem.txt. You load the file into a variable called as file, and then you say for line in file, you print the arrow and then the line. Okay, so this is where it is. It starts from here. In the second para also, it starts from here. In the third para, it starts from here and moving forward. You can see everywhere where the line is starting. Now it is clear, everywhere we see an arrow, that is where a new line starts. Python is interacting through the for loop once per occurrences of these arrows, correct? So interesting, let's see if we can read the same file twice. Okay, guys, I hope what is written here is clear. So let's see. What we are saying is Python is considering these 1, 2, 3, 4, 5, and 6, and 7 blocks of line. Okay, let me open that data file. I think I can open directly from here. I can go to this part, can go here, and lorem.txt. So when I open this file, you can see that this is block number 1, this is block number 2, you can see. Okay, so this is block number 3 and the 4. And what we did in the code, we actually said you read it line by line. So it did not read lorem first and then the tempor and then moving forward, right? It actually took this piece of block as an entire one-liner. So how many loops? So if you want to really see that it is working this way, you can use an enumerate function. I hope everyone remembers the enumerate function. You can use for something dot something enumerate this part, and you can get the count of enumeration. So technically, it should have around 7 count of iterations over there. Niranjan is saying, can we use regular expressions to filter data from the file? Is there any library? That is correct, Niranjan. You can very well do that. But that's again a part of data processing. We are simply reading the data right now. And if you want to do that, you can read the data in a file variable, which you did. And later on, you can use a regex, regex, which is a keyword or maybe function, which you can say is readily available as a library in Python, and you can very well use that. If you are good at regular expressions, you can do it. Otherwise, you will have to use a regular expression interface to actually find out the expressions. So can we open particular paragraph? Swapna is asking, I think we can, but I'm not sure. You can try, Swapna. We are reading line by line, so you can specify that if you want to read a specific line. Yes, I think we should be able to do that. I can try it. But yes, the answer is yes, you should be able to do that. All right, so I'll just go cell and current output is clear. So interesting, let's see if we can read the same file twice. So we have already read the file into a variable called as file, which is again open. And we're saying for line in the file, you print the line. For line in the file, you print the line. Okay, if you can see that we have read that, we have written this for statement twice. So one is with the arrows, the other one is without the arrows. Okay, so that means whatever the 7 paragraphs of this text should convert into a 14. And out of that, the 7 should have the arrows and the other one should have the dashed lines over there. So when I try to run this, it actually runs this, 7 times, 7 lines of code, which we have in this. And you can see that's the end of the statement. We did not get the paragraphs with the underscores or the dashes over there. Niranjan has a question. Okay, sorry. Yeah, sure. Thanks, Niranjan. Rushali is saying, can we open Excel files and .mat files in Python? That's a good question. Excel files for sure, yes, you can. And .mat, I guess you're talking about a matplot. So .mat file is from the SAS, or it's from the MATLAB, correct? So it's from the MATLAB model files. Rushali, actually, really, I haven't checked that. So Excel files, yes, sure, we can do that. but not sure about the .mat files. But there should be a library specifically to open mat files. Because I'm not sure in that, because MATLAB is a proprietary software which runs under licenses. So there's a reason I'm not sure about that part. So you can recheck that on the Matplot or on the Matplot site, because these proprietary softwares, they have they want DLLs to connect to their models, and there are different things. Okay, so we wrote the for loop twice to read the file, but it seems like the second loop did not run at all. So this is true because the for loop is interacting the file pointer, which is moving forward one line at a time. So when the first for loop completes, the file pointer has reached the end of the file. And this is also the time when the for loop breaks, as there is nothing else remaining to read. Okay, so that means the second loop, which tried to run the file again, did not run because the file pointer had actually reached the end of the file. So when the second loop is running on the same file object, it's nothing more else to read. So the second loop does not get any additional data. So it does not iterate at all. So the loop simply quits and the file has already been read. So what is the thing that we have got is, it is important to keep in mind that once the file is read, we cannot reread something that is already read, and we must appropriately manage and handle what is being read and what is being assigned and saved. Okay, so until the next time we need them. So this is an important thing, that when you open that, we should also save, or we should also close a file. So what happened in the previous case, that why we couldn't run the second for loop, because the file was still open and the pointer had reached the end of the file because of the indices. And since the file was still open, the pointer did not get reset over there. So that's what we saw, that even though we finished reading the file, we had read it all the way to the end, the file was still open. We must explicitly close a file, and then we can try opening the file again. Also, it is important to close a file which is an open file, which consumes significant amount of resources, because when you're opening a file, I'm sure you're not opening a file to read a couple of records. You're opening a file to read maybe millions of different records which we have in that. And what is the requirement that in what scenarios that we get text files as an input in Python? There are many scenarios. If you're implementing a data science system for your data centers, then your deal is with your logs data, right? When the machine got restarted, or when the update was done on the server or the hardware, when the licensed patch was applied. All these reporting things are happening. Or, you use all those paraquat files, and server log files typically. So if you're working for a data center reporting, you are using a log files, plus you're using different other formats of files to bring that into as an aggregator. So using pandas in Python, you use that as an aggregator to bring all the data into one roof, and then manipulate, transform, and process, and finally create a new data set. You can call pandas as an ETL of data science. So when you do this ETL, it is important to open and close certain files. Okay, so we have opened a file, but we haven't closed it yet. So let's see. There's an important points there for computer science people who are not from computer science engineering background, that typically to this one, that when you open a particular part like a file in a computer, it is important to close them, because there is significant amount of resources which being occupied by these objects, like say some kind of part of the memory, some part of the program, which might reduce the bandwidth for you to work. All right, so so if you relatively reach that point, you'll no longer be able to load any more files. So for that kind of stage, we won't let it come. So let's say file.close. And when we close this file, I've closed that file. So the close function can be used on the file just as an open function. And you can invoke close on an already closed file without any problems. However, once you close a file, you will not be able to read it even you have not read the first time around. Okay, so let's see this. So file.close, I've already closed it twice and it's not doing anything, correct? It's been closing again and again. And when you try to again reopen this file and then close it back and then try to read the contents of the file, it's going to give you an error. All right, so let me just go to the cell and clear the output. So until this stage, it's clear to us, correct? After closing, when you're trying to gain access to that file, that's where we have a problem. Output operation closed on the file. No, Manikanta, that's not correct. So he's saying instead of writing for, can we use file.head or only file? No, we are using for loops to iterate that file, correct? We need to read the contents for that file. Rushali, please later also show for Excel files. Rushali, for Excel files, you will have to wait until the Pandas session, because in Pandas session, we're going to read Excel files. Funny is saying, shall we open PDF files? For PDF, there's a different library package, Funny, in Python. I'm not sure it is PDF only. You can very well read the data from PDF, but it's not very straightforward. You need that latex library. Priyadarshini, is this generally used in updating the contents on the website or for creating a new website? Actually, that's a good point, Priyadarshini. For content management activities, yes. So if any blogging site you have, you can very well manage your entire blogging in an automated way by writing a full-fledged automated solution in Python. Aparna is saying, is there any explicit way to move the file pointer to the beginning of the file without closing it? We are reading the file line by line. File.reset is not an option. File.close is an option. So you need to close the file before you can reread it. A Rockstar is saying, can we take pointer to start to read it again? So I've already answered that, Rockstar, but we can see. So see these kind of questions. So let's say you can evaluate by yourself. Okay. So let me comment this. Okay. You say you open the file. Okay. You have already opened the file. And what kind of operations can we do on the file? Can you see this? You can explore it yourself in case you can see there's a closed, a detach, encoding, UTF, or ASCII encoding you want to do, file number. So you can very well go to these options and see new lines, read, which we have already done, like a read. Seek is a function which is also used in many different programming languages. So this probably can answer your question. Seek could be, we can see we can see what are the arguments to seek function, or we can do that in just a moment. So we can write. So far we have just written as write or write lines. We are yet to see read lines or read we have seen. So we saw read, right? So we saw open, and we can actually read this file. There's an option called as read lines. So this one will answer if you want to read a specific block of code. So we had 7 blocks. Let's say you want to read only the 3rd one or only the 6th one. So those options are very well available onto this one. So I hope this helps. Okay, so this is clear, file.close. And when we do this, we're going to get an input-output error, which we cannot ignore. Abhijit has a question. Yes, my path is home Jovian, and is it possible to open any text file from a laptop or C drive? Yes, you can do that. So the only thing is you will have to first go on to the upload. If you can see my screen, you can see there's an option to upload. Okay, so you can upload your file, which is your local computer. You can click here, it will point to the file and it will start appearing in your working directory and you can very well import it. So when you read the file, there are different modes that you actually read the file. Okay, so let's look at this quickly. So Python supports specifying the mode in which you wish to open the file. So there are a couple of modes, and the most default way that we read is actually the R for read-only access. So, but let's see what are the available different modes. R is for read-only access, and let me tell you guys that these read options which are specified on the screen are just some part of that. Okay, it is not. This is just the when you go to the text, which I'm going to show you the documentation that is comprehensive. I'm going to guide you on to that once we finish this part a little bit. And you can read it yourself that there are several different modes available that you can gain access to your file in a specific way. So R is for read-only access, W is to write-only access, but W creates a new file by overwriting an existing file. I mean, this is like you cannot let your repository let it be exposed to people who can really create a mess out of that, because when you are a serious programmer working on a particular solution, you need to ensure that your repository is completely safe. No new developer should come and mess with your repository, like deleting a function or kind of tampering with your files. So W is to write your files, but you create a new file and by overwriting any file which is available. X is write-only access, but fails if a file with the same name is already present. So you don't want any other developer to add contents to your file. He should be creating his own file. So X is something that you can use. A is write access to append to a file or creates a new file if the file does not exist. And R plus is basically open for both read and write access. I think we did with the R by default. So let's see what is the argument by default for open. You can check it yourself. So I think you can go to the file, which is, sorry about this. You can go here. You can see there's an open keyword. Okay, open question mark. And you can see that there is, I'll open this in a new window. You can see that there's a lot of options. Okay, open a file and return a stream. You can see these ones. Open to fall for reading. So you can see this one. I said that we did not specify the mode when we used the open function. Why we did not do that? Because we simply want to demonstrate how to read a file. And the another reason for not to specify the character for the reading is because by default, R is used for open for reading. Okay. And what are the other options? You can see the open, the file location, and the mode is basically R, which is by default available. There are other different modes available. So let's go and check on the other ones. So you can go here. Sorry. So there's a lot of data that's actually being read here. So more or less, we saw these options. So we can also additionally specify B and T to instruct whether the file should be open in binary or text mode. We saw that in the documentation. If we specify mode as RB, that means the file should be open for read only, which is the default, but in binary mode. And if we specify RT, it means we should read only access, but text-based reading. If we specify just R, then it is essentially defaults to RT. All files are open for text mode operations with not binary mode operations. So as an example, you can see file is open. And in the earlier statement, we did not use R. We simply specified which was default. R was default, so we did not use it. And when you try to load this, definitely it's going to return the same as what we saw before. So, but if we don't specify the second mode, specify a mode, the file is open in R by default, which is for the purpose of reading. We won't be able to write to such a file or modify contents for such a file. So if you have opened a file in the R mode, you can make changes in that file, but you won't be able to save it back. Especially, you must have seen the host file on the server, hosts.txt file, which is located in the etc folder on your Windows machine. That host file is used for looking up your IP addresses to the host names. So in case if you're trying to access an application with an IP address and your DNS is unable to look up, you can mention that IP address and the relevant host into the host file. What happens is when you try to edit that host file, if you simply read it with the read correct, so when you don't log in as a Windows administrator, you simply log in with a normal user, you try to open that file, it will allow you to make the change. But when you're trying to save that file, it will always ask you to save with a different name. And that's where the administrators have the flexibility to restrict users for changing any system files which they have, especially for system files. You can keep your default reading mode as R, wherein people can simply read it, but they should not be able to make any changes like any IP address changes or any DNS mapping changes over there. Okay, so this could be the usefulness of that. So let's go with, so if you want to open the file for writing, then do not accidentally use W mode, because you must at all points in time use A, that is for append, or R plus mode, unless you definitely want to use the W mode. So what does the W mode do? Write only access, but creates a new file by overwriting any existing file. So this is like a very, very risky operation. Any other person or colleague can, as an accidentally can open a file, can clear the contents of the file and can resave that file back, so that when you come back and look at that file, it's completely empty. So the file size is 0 bytes. And that's where you're going to get a heartache over there, because you really had a hard work delivered onto that part. So never W is to be used unless you are really sure what you're doing. Okay, so let's use with statement. So we have seen so far only open statement, we have seen close statement. Okay, but let's see what is the with statement up to. So in most cases, we will use the with as statements to work on files if you want to open a file to do work on. So the with as will automatically close the file once you're done working on, in case you forget. Just like the way you have attach function in R, if people have heard, similar to that, you can say that with this file as some file. So when you read the contents of this file, after reading the content, the file is automatically closed. Especially when you read imagery data into Python, you do not want to keep a track of what files you have open, because you might use multiple folders to gain access to any kind of an imagery file. The reason I'm saying imagery files, because they are really heavy, of around 3 or 4 MB per file, and you might be dealing with thousands of files. So that can really occupy GBs of your system memory. So it may happen that you tend to forget to close a specific file and you later realize it. So it's better to use a with. So what happens? So in most of the cases, you will use the with statement to work on files. If you want to open a file, do some work on it, and then forget about it, then with is your best choice, because with is automatically closes the file once you are done working on it. So you say for file and file, you print the line. So the moment the last image file is printed for you in the Jupyter, the open command will automatically be disabled, and the file will be closed for you. So as an example, so you can use this. So, and when you run this and when you try to again gain access to your file line in the file, it'll give you an error. So the above block of code is exactly the same thing as before, but it is a much safer implementation. Okay. Creating a file, writing to a file. Let's see this. with open. So when you're opening this file, you're specifying. So now the closed worry is gone from our side. So we don't have to write the explicit code for the closed because we are no longer needed that code. Once we are done with that, reading the file or doing some operation on the file, Python will automatically close that for us. But what still worries is that when you open a file, in which mode you would like to open it, file will be closed automatically. That's of no problem now. With open hello.txt, you open the file in a write format, file.write hello world. So the moment you write into the file called as hello world, it'll close the file automatically for you. That is a good point. Supreet says for closing all open files if we do not remember the file name. But yes, keep in mind, not all open files. If you have used with specific files, only those files. For those files in which you forget to write the with statement, that's where you will have to close it manually. So now only thing is we need to think of the different modes which we have. So open hello, we are saying that you read this, you do this into the write mode. So what did we see? What does a write mode do? So you can see no output, but I can assure that you have now created a new file. So let's say open hello.txt. So do we have any file here called as hello.txt? What is the path? It's simply hello.txt. So let's go to this one. Do we have any file called as? No, we do not have any file called as hello.txt. And I'm going to run this file. So what is going to happen that the moment it sees that it's a write statement, the mode is write, but the file does not exist, it's going to create the file for us and going to write this hello world for us inside that file. I'm going to refresh this and see if the file did appear. Yes, you can see just a few seconds ago, this file got created. And when I click on that file, it says hello world. So our contents are also written in that file. And we don't have to worry about closing the file because we used a with statement. So file is already closed. So we wrote the contents. To a file and Python automatically closed it for us. So this file can no longer be accessed unless we open that file again. Okay, so that's what. So you see no output, but I can assure that you have now created a new file and written a single line inside the file that is in a hello world. So let's go back to the file list and check if we have created a file. Open the file and see if we have found a hello world in that. And you can open the file, indeed confirm hello world is written to it. So that's what we did. We saw that file is indeed present with hello world text written in that. Now let's see what happens if you perform the write operation in a loop. So let's say list of range 0 to 10 or 0 to 9 typically we have in this. So we create a list here. List, sorry, of 10 numbers. And then we're going to use, so you can see how swiftly we can use with open statements along with the conditional for loops. So for X in the list of whatever, with open hello.txt, which we have created in the form of as a write statement, you do file.write hello plus the string of the X, which is 0 to 9. So it should be 0, hello 0, hello 1, hello 2, correct? Let's run this file and let's see what's going to be the output. We have successfully run this file. Let's go back to our hello.txt. I will refresh this. And let's come back to our hello.txt. Click on this and we find only the last entry of that loop, which is an hello 9. We were expecting it to be hello 0, hello 1, all up till hello 9. But only the last value got printed inside this particular one because we are using we are using what? We are using a mode which is W. So it opens the file, clears the contents, replace the existing content with the new one. In the second loop, again, it opens the file, replace the file with the new contents. So the last entry is just to be remaining there because there was no other replacement which it had. So hello 9 was the only last entry which we could get in the file. If you want to really start with a 0, all up till 9, then you will have to use some other mode to do that. And I think the best mode suitable this would be for this could be the A mode. I think the A mode was for the append mode, but let's see what does the document tell us. So while again there is no output, so we can be rest assured that your file got written 10 times. You use the W mode. So each iteration. So what happened is for range number 0, it opened the file, printed the hello and 0 for you. Then it came back for item number 1 and opened the file again. And since we're using with, so the file got closed automatically. Again, it got opened, again closed, again opened, again closed. It did this almost 10 times. Actually, that's correct. Aparna, you're right. The mode should have been for appending, but the mode which we are using is actually for overwriting. So it opens the file, clears the contents, places the new content, and closes the file. Again, it goes back, opens the file, replaces the contents, closes the file. So in this case, the more appropriate thing is to use, this is all the same explanation which I just did because of it element being the last iterative element. That's what we got saved in the variable. But what if you want to print all hello 0 all up till hello 9? Okay, so we need to change the mode. And the mode which is recommended to us is actually an A mode, and A mode stands for append mode. Open the file, place the value, close the file, then again open the file, append the value, close the file, then open the file, append the value, close the file, and that's what this is going to happen for X in the list with open temp whatever. So this file does not exist. So it's going to create that for us. And let's run this code and refresh. You can see that there's a temp.txt, and in a very ugly way, this has been printed in the file about hello 0 and the hello 1. And in fact, the 0 is very far from the original text. So it's actually 0 hello and 1 hello. It's not hello 0, hello 1. So we need to make sure that this works. Yeah, so that's what I'm showing to you, Supreet. So this is the script. If you want all the 10 values to be printed, this is the script. But we see that the output is being written in this way, correct? But we don't want the output in this way. So what happened here? The only thing we changed is the file mode. We used A instead of W, where we opened the file got appended and somehow got closed. Okay, so we can see that hello from each iteration loop got appended to the file, etc., etc. The only thing is that we did not specify the new line character over there. Now we can see that hello from each iteration for loop has got appended, but still it did not come into different lines. So if you want to bring that into a new line, what we have done is file.write, same things, no different change. Hello, concatenate that with the number, and then start print, but with a new line. Okay, let's run this. And let's go back to our temp2. So this is temp, and I'm sure there would be other temp2, which is here now because the name of the file was temp2. And you can see that we've got the observations 10 times. And we did not use the previous values here. It's all being considered. So each iteration of the loop got written to a new line. This is so we put a /n at the end of each line. And this is an escape sequence character that represents a new line. You can simply say, we simply say it's a new line character. We are not covering the escape sequence characters for some reason. Okay, so I hope this is clear. There's another things, to write multiple lines. Let's see how different this is. Yes, exactly. So Bobby has a question. Will the A mode also create a new file, which actually it did. So you can see that in this one, the temp2 did not exist. Okay, so the temp2 did not exist. And when we used the append operation, it did create a temp2 for us, which previously wasn't there. What is this writing multiple lines? So in a single go, we can write multiple lines to a file by using the write lines function. So let's see this. So first is you create an empty list. Okay, so this is creation of an empty list. Create a list of 10 numbers. Integer number, I should say. Lines that append hello, append hello text to file. Actually, append hello text to files. This is to list. It's actually a list. There's nothing, I'm not doing any file-based operations in this code. I've simply used the empty list, and then I'm saying that whatever this list you have, you append that like an hello whatever 0 plus the new line into the list. And now you open hello.txt file. If it is not there, then you create it. You remember we had seen the options in the file. One was file and the other one was write, and the other one was the write lines. So this is what we're using. So with open your hello.txt, which is not present, you can create one. So I think hello.txt is actually there here, but I can delete this. I want to delete this file, and the hello.txt is not present in my repository. So with open hello.txt, it's going to create a file for me in a write mode, file.write lines, which is this one. Let's see what happens. I'm going to go here. The hello file has come here. Oops, that's so nice. Instead of we doing the other thing, what we saw in the previous code, by actually using an append mode, we did this in the W mode, because the W mode considered this as the whole text, because it was loaded into a single list. So in the above example, we created a list called lines. We filled in the values and then passed into the list to write lines in a single function call. All the strings present in the list got written to the file. So if you have a list of data, or you have your data in a list, you can pick the entire chunk, means the complete list, and dump it into your files. You don't have to iteratively iterate into picking up one by one lines and doing that part. And now if you open the contents for hello.txt, which should find just these things, which we saw, hello 0 to hello 9, which is already there. So same things, multiple ways. Write is to write a line, write lines is to write the entire paragraph. Deleting a file, so we can delete a file in Python by using the OS module. So import os.remove this file, and remove all available file which we have here. You can see that all the files actually got cleared from my repository, from my working directory basically. So removing a file is very simple operation provided by the OS package. After you run the file, you will notice the previous created file has now been deleted. It is important to handle errors here. So if you call the remove function to an inexisting or already deleted file, it will throw an error. So if I say import os.remove, it's going to throw an error, or even if I say hello.txt, which was present earlier, it's going to throw an error called as file not found. So this concludes this session. So file reading and writing has a lengthy operations. There are several additional functions you must know for properly working on the files. The idea for these notes is to give us a good jump start of how raw file operations operate in Python. In practicals, we will also likely to see pandas for performing various files-based operations for the purpose of data science, as I said before. However, if we must use some of the raw file operations, we recommend studying these things further. And you can very well look at these particular documentations. And there possibly could be the usefulness of, even if we try these functions one by one, that's going to give us a good exposure to these ones. So this is how we basically conclude your Python core. Any questions? I hope the session was informative. Aparna's question is, how do we handle these errors of not file found? You can write an exception handling code. The example for this is not there in this book right now, but I can encourage you to look at exception handling in Python from Python core, which is not demonstrated here, but it's pretty simple. You can write an exception wherein if the file is not found or if there's an error, then you print the statement called as the file not found. I'm not sure for which code you're getting this error, Abhijit, so you can paste the code and you can see. You can see if the text file exists and also check if the name of the file is exactly identical. Python is case sensitive, so even a small character change will change the object. Thank you, Sunil, for that. Yeah, sure. I always strive to make it informative and productive, obviously. So yes, thanks, Sunil, for that. Thanks, Aparna. I always recommend to move this and practice these notes.
Thank you so much, Suvir, for the session. And thank you to all of you for attending. I can see that there are some more questions. We're almost at 1 o'clock, so let's take a quick lunch break. And we can be back after the lunch break at 2 p.m. It's the new link. You can see that on the YouTube channel. Before you go, do not forget to subscribe to our channel. Hit the bell icon so that you're notified whenever a new session goes live. And if you like this video, please to like it, please to upvote it. We would really appreciate to get your feedback. Right after lunch, we will begin with Numpy. I'm sorry about that. We'll begin with Numpy. And Numpy is a really interesting framework for you to handle arrays and multi-dimensional data structures in Python. It's an important concept and a key concept when it comes to doing any type of data science. So most programs that you write, most data science programs that you write, you will write it from two sentences, which is import NumPy as NP and import pandas as PD. These are two things that you will start with. And we are now going to focus on from the second session today all the way till Sunday evening. We're going to focus on making sure we cover everything with NumPy and pandas so that all of you are extremely well aware of these frameworks. And this is the most complicated it is going to get. Your journey in machine learning, when you continue onto machine learning, is actually much simpler than doing NumPy and pandas. So let's get ready for it. And we'll be back after a quick lunch break. And do not forget to make your submissions for 7DC, which is the 7 days data science challenge. And we at 4 p.m. today, which is just before the close of the next session, We will show you the leaderboard as of yesterday night. And then you have a few more hours remaining to make your submissions and regain those ranks if you're not in the top position. And to all those on the top position, keep in mind there's insane competition and we're getting insane number of submissions right now. Our trainers are literally going crazy evaluating all of the submissions. So all the ones who are on the top, be really careful. You have to be good. And unless you have a full score, you need to really keep submitting because somebody might just beat you at it. So we'll see you again after lunch break. And thank you so much for joining in today.